Hi everybody, welcome to day 23. We're going to look at 7.11 variation functions. Let's just remind ourselves about some of the properties for variation function or for functions that we've talked about before. We've got the add property, and that helps us determine linear functions, quadratics, cubics, etc. Remember, the add-multiply property is for exponential functions, and multiply property is for variations, right? So multiply x by something, multiply y by a constant, all right? But what we're going to look at is we're going to look at a little deeper of the multiply property for geometrical objects. So one thing to keep in mind, all right? Linear dimensions are directly proportional to other linear dimensions. Area is directly proportional to the square of a linear dimension. So we can think if we're looking at, let me take that back. So if we have a linear, it's going to be directly to another linear. If we have area is direct to the square of a linear function, and then volume is going to be directly proportional to the cube of a linear function, okay? So kind of keeping that in mind, what we're going to do is we're going to look at two examples, the first one being the egg problem, and we're going to use this concept for the geometrical objects, all right? Here we go. Okay, so looking at this first example, according to an ad for South African Airways in an old issue of Time magazine, ostrich eggs are served at bush country barbecues. Each ostrich egg is claimed to be equivalent to 2 dozen chicken eggs. So if an ostrich egg really is equivalent to 2 dozen chicken eggs, and a chicken egg is about 6 centimeters long, about how long is an ostrich egg to the nearest centimeter? Okay, so we're going to use this idea of this multiply property. We are going to talk about length of the eggs. So we're going to say the chicken egg is a length of 6 centimeters. We don't know the ostrich length, so we're going to call that L for now. We're going to talk about volume in terms of the number of chicken eggs. So a chicken egg has 1 chicken egg, okay? But we were told that 1 ostrich egg is 2 dozen chicken eggs. So 2 dozen, we're going to say an ostrich egg is 24 chicken eggs, okay? And now we're going to use that multiply property. All right, so let's just kind of think about how that goes. Well, if we're comparing length, right, I know that I'm going to take 6 and I'm going to multiply it by something. So let's just call it x. And if we're comparing volume, we know volume is directly proportional to the cube of the length. So I need to take whatever that x value is and cube it, okay? So it's times x cubed. So this aspect right here will allow us to get started and to find what x is, so we can then find what the length is, all right? So if we set up our equation, we have 1 times x squared equals 24, right? So if we take the cube root of each side, we're going to get x is equal to the cube root of 24. If you throw that onto the calculator, you get about 2.88 something, but we can keep it exactly as the cube root of 24. So now we just go back over here and we say, okay, we're going to take 6 and we're going to multiply it by this x value to get the length of an ostrich egg, okay? So we're going to take 6 times the cube root of 24, and that's going to equal L. All right, so this equals L. So if we plug that into our calculator, all right, we're going to get L to be about 17.3, okay? So if we answer the question to the nearest centimeter, how long is an ostrich egg, right? An ostrich egg is about 17 centimeters. Our work is this table. That's good enough for us, okay? So now let's take a look at part B. a robin's egg is 1 centimeter long. How many of them would you have to take to scramble, or how many would you have to scramble to get the equivalent of 1 chicken egg, right? So we're going to use the same concept, right? We're comparing length to volume. So now we know chicken eggs, their length is 6 centimeters. Robin's eggs, 1 centimeter. We know the volume, 1 chicken egg. We want to figure out the number of eggs in terms of chicken eggs for a robin, okay? So it's that multiply property. We know we're going to take this, we're going to multiply, right? And how do we get from 6 to 1? Well, we're multiplying by 1/6. So using that multiply property, and remember, volume is directly proportional to the cube of our length. All we have to do is multiply 1 by 1/6 to the 3rd power, okay? Which is really just 1 over 216. All right, so a robin's egg is 1/216th of a chicken egg. So then we have to think, well, how many robin's eggs to make 1 chicken egg? Well, we just interpret it and we say, well, if a robin's egg is 1/216th, then it takes 216 robin eggs to make 1 chicken egg. Kind of crazy. All right, let's take a look at the last example and we'll be on our way. All right, so we're going to look at the grapefruit problem. So suppose you're shopping at a supermarket and find that Texas grapefruits have twice the diameter of Florida ones, but they cost 7 times as much. Recalling that the volumes of similarly shaped solids vary directly with the cube of a linear dimension, such as the diameter, you will instantly determine which kind of grapefruit gives you more for your money. So which one is it and why? So again, we're going to be comparing a linear dimension, diameter, to volume. So it's just reminding us that volume is directly proportional to the cube of that linear function, okay, that linear dimension. So if I've already created a table, go ahead, create this table, right? I'm just going to talk about the Florida. I don't know the diameter of a Florida grapefruit, so I'm just going to call it 1 because it's easier to work with. The volume, again, is just 1 Florida grapefruit, okay? So then I know that a Texas grapefruit is twice the diameter, right? So all I have to do is multiply this by 2, okay? So then to get the volume of a Texas grapefruit in terms of a Florida grapefruit, we are going to multiply by, hopefully you're saying it to yourself, 2 to the 3rd power, right? So what we get is we're going to get this V to equal 8, right? Okay, so we have to think about it. It told us that a Texas grapefruit is twice the diameter, but it costs 7 times as much. So if I take a look, twice the diameter, but let's look at the volume, okay? So thinking about the fact that the volume is 8 times the volume of a Florida grapefruit, which one is going to give you the biggest bang for your buck? All right, go ahead and answer that question. I'll give you a second before I reveal what I found. All right, so go ahead and do that. Hopefully, you recognize that the Texas grapefruit is going to give you more bang for your buck, okay? So a Texas grapefruit is 8 times as big, but it only costs 7 times as much. That's a deal if you ask me, all right? If you do have any questions, feel free to ask, and I'll see you later.